My name is Soleil, and today we're joined by Santiago and Alexi from Chainsafe. Santiago and Alexi, please introduce yourselves, and then we can start with the workshop.
Okay, hi everyone. Nice to meet you. So I am Santiago. I'm the developer relations for Web3.js, and here is Alexi.
Yeah, I am senior engineer from the core Web3.js team.
You can follow us, or you can text us in anything if anything comes up. If you have any questions, at Santiago.rel or at Kosinski on Twitter. Welcome to this workshop. We learn Web3 DAO and kind of push protocol as well that is supporting us here. This is what we are going to cover today. First, I'm going to walk you through a Web3.js intro so you know what is Web3.js in case that you never hear about us. I'm going to show you some basics of Web3.js, like how you can deploy a smart contract, how you can send a transactions, how you can listen to events. And I put some code snippets in the slides, so you're able to copy paste this and then reuse that for the hackathon. Then we are going to talk about Web3 plugins. What are these Web3 plugins? Some specific examples that we have. Then I'm going to cover the hackathon and the Ideathon criteria because we are having two different things. One is the hackathon, that is for building a plugin, and then one is the Ideathon for creating ideas for plugins, but this is no code for the Ideathon. And then at the end, we are going to have Alexi, who will build one or two plugins, and then you will be able to understand and see the whole process in a live version to build the plugins. Okay, so now let's start with this Web3.js intro. So Web3.js is a JavaScript, a TypeScript library that allows you to interact with the Ethereum JSON RPC API. So normally, if you want to interact with any blockchain, what you need to do is the things that you see above in the slide. You need to send these raw JSON RPC calls, right? But then if we want to build dApps and we want to have more adoption among developers, we cannot have these complex things, right? So then Web3.js is kind of wrapping these calls in JavaScript and TypeScript. Like for developers, we are written in TypeScript, but then anyone with JavaScript is also able to use it. And then to do the same RPC call that you see above, you can just use the code below that you see. You need to initialize the Web3 instance. You need to import the Web3 library, here. After that, you need to initialize a provider. And then you are able to use Web3.js. In this case, I have web3.it.get block number, and then you will get the block number, the latest block number of the Ethereum mainnet. Okay, so this is a basic dApp communication flow. So normally you have the dApp, can be the MetaMask, a React app, or any other protocol. Then this dApp is using Web3.js, right? And then Web3.js will connect to a provider. This provider can be QuickNode, Infura, your own node, or you can also find some RPC providers for free in chainlink.org. And then this RPC endpoint will communicate with the blockchain. And then the blockchain node will write the transaction or will retrieve the value of the call or whatever that you have done. Okay, a short timeline for Web3.js that was created in 2014, 10 years ago by Jeffrey Wilke, one of the Ethereum co-founders. And then Merek from Parity Tech also joined him in 2014. Then in 2015, Fabian Vogelsteller, the ERC20 token standard creator, took over as a lead maintainer. And so far, he's still the number one all-time contributor to the Web3.js repository. Then in 2020, Chainsafe took over as a lead maintainer of the library. And so far, we have around 1,000 pull requests from contributors from 2020. And then we also have 18,000 stars on GitHub. And we launched actually version 4.6 a few days ago. So yeah, we are still really committed to the library. Some people are really aware about version 1. Like most of the people before, they were using Web3.js version 1. But now we came here and we rewrote the whole library. And now we have version number 4. Some of the milestones that we have at Chainsafe are that we rewrote and refactored the whole library from JavaScript to TypeScript. So now it's better and more maintainable as well. You can use ECMAScripts and CommonJS builds. So you can import, you can use these to import statements, import or const. We also decreased the library size from 300 to 329 kilobytes to 156. But this is the size of the whole library. Web3.js is composed by different packages. So if you use a specific package, you don't need to download the whole library. So of course the size will be less than this. We also have revamped documentations with all the APIs. We have guides and tutorials. I have published some videos. So Lexi as well published a great Web3.js course. And then in terms of usage, so far we have around 2 million of npm downloads per month. And last time that I checked was 19 million of CDN requests. So yeah, we can see that some projects are still using a lot of Web3.js, which is great. Perfect. That was a lot of theory. Now the basics of Web3.js. So this is the most important thing, how to install the Web3.js library. So you need to create a Node.js project. And after this, you just need to run npm install or npm I Web3. And then you will see in your package.json that in the dependencies that you will have Web3 library there, the latest version, in this case 4.6. Something really important that you need to do this all the time is that you need to, of course, import the library by typing const web3 with uppercase and also with these curly braces. This is a mistake that I have seen in a lot of different projects, that to import Web3.js version 1, you didn't need to use these curly braces, but now you need to put them for version 4. And then you just import this from the Web3 module. So you can use these two import statements. And then you need to initialize a provider. So this provider will be the RPC endpoint that Web3.js will use to communicate everything, to send the transactions, to interact with the blockchain, to fetch the data, to make the calls, to interact with the contracts. So depending on the provider that you use, you will be talking to that blockchain, right? In this case, if we use this, we are going to talk to the Ethereum mainnet. But then if we change this link for another one, for Mumbai, Sepolia, then we are going to interact with these other EVM networks. Perfect. So here, for the basics of Web3.js, I kind of put some important things that you can do with the library. So if we go to the first one, that is fetch data from the blockchain. This is actually using the ETH package from the Web3 library. So the first thing that you need to do is this one, to initialize a provider. So once you initialize a provider, we will have this const provider, and then we will need to use this provider to do everything, right? So that's why, I think we got a question. You can just take a look at that. So that's why I have here provider. In most of the example in the documentations, we put Web3 in lowercase, but I just put provider to make it like easier for other people that comes from ethers or VM or just is getting started. It's just easier to understand provider instead of web3.eth sometimes. So I put provider. So everything that you want to do to use Web3, you need to put provider.something, provider.utils, provider.eth, or Web3 in case that you initialize that variable with the Web3. So provider.eth.get gas price, and then you will get the gas price, right? Or .eth.get block number, and then you will get the block number, the get balance, and you can send an address here, and then you will get the balance of this account. So this is how you can fetch data from the blockchain. Pretty simple. Install the library, initialize a provider, and then use the provider ins to access the ETH module, and then just explore the different methods. Here I have the link to the documentation in case that you want to know more about this. Perfect. The second thing, which is really important, is interact with wallets and accounts. So we have two important, let's say, objects in the Web3.js library. The main one is accounts. Accounts is basically an object that will have a private key and an address, right? And a wallet will be an array that will hold or can hold several accounts, right? So we always need to initialize a wallet with an account inside to be able to interact with contracts or send transactions. That's why this is really important. And then how we can initialize a wallet. So here I have the code snippet. We need to type provider.eth.wallet.add. And then we can put a private key here, and then we will be able to interact from this wallet. So if you want to send a transaction, to interact with a contract, you will be able to interact with that using this. So this is how you initialize the wallet. And then if you type my wallet in the position number 0 dot address, you will get the address of that account, or the same with private key, you will get the private key of that account. And then if you use this provider.eth.wallet.add. Again, you will be able to add another account to the wallet. So that wallet can hold like several accounts, but yeah, in this case, we just need one. And then the account methods, we can also add we can also access those account methods by typing my wallet in the position 0 .sign transaction. Then we can just send a transaction object as a parameter, or .sign, and then we can just send the data. Here I also put some links to the accounts and wallet modules in case that you want to know more about this, but this is the basic that you will use everywhere, so that's why I put it in the presentation. To deploy smart contracts, perfect. So to deploy smart contracts, the first thing that we have to do is to initialize a wallet, because when we deploy a smart contract, we need to send this as a transaction from a wallet, right? So this, in this case, will be from this wallet. Then something really important that we will use also a lot is to initialize a contract. So to initialize a contract, we just need to type new provider.eth.contract with this C uppercase. Then we will need to send the ABI. And if you have, okay, in this case, if you deploy the contract, you don't have an address, but you can also only send the ABI, and then you will create a contract instance. After you have this, you need to create a contract deployer. This contract deployer is just taking this contract instance, which is my contract, .deploy, and then you just need to send the bytecode. If you wonder how you can get the bytecode and the ABI, this is pretty simple. You can go to Remix. Let me actually just do that to show you. There are different ways, but this is kind of the easiest one that I use. So for example, if I have this smart contract here, what can I do is I come here to Solidity Compiler, and after I'm here in Solidity Compiler, I can copy the ABI and the bytecode from here. So yeah, that's how you can get the ABI and the bytecode. Okay. So yeah, we need to create this deployer, which includes the bytecode here, and then the arguments in case that your smart contract has any arguments for the constructor that you need to send. So you just need to open this array and then send as many arguments as you need, or nothing. And yeah, and then after we create this deployer, we can send the transaction, which is sending this deployer. So to send transactions, we always need to type .send. So that's why I have here await deployer.send. And then we need to just open an object here, including the wallet that we are like sending the transaction from, right? So again, we need to type my wallet in the position 0 .address, or you can just directly copy paste your address. And then Web3.js will do the magic behind the scenes. We'll sign the transaction, we'll send the transaction to the network, and everything. So yeah, that's why creating a wallet is really important when you want to use Web3.js. Interact with contracts. So this is really easy because we don't need to, so this is the reading functions. Yeah, so for the reading functions, actually, we only need to initialize the contract, which is const my contract with the same thing, provider.eth.contract, the ABI and the address. After we have this, we can just make the call. So how we can make the calls? We just type the contract instance, which is my contract.methods.function name. So this function name will be the function that we are calling in the smart contract. And then here in this parentheses, you can put parameters in case of that function parameters.call. So this is really easy to make calls. Is really easy for smart contracts. Just .methods.function name.call and the contract instance here. You can copy paste this code and that will work. You just need the ABI and the address, and of course to initialize the provider. Okay, and then to interact with writing functions, first we need to initialize a wallet, provider.eth.wallet.add, then private key. After you get used to initializing wallets and contracts, this is kind of easier. Then you put the private key of your wallet. Remember that you need to have funds in this wallet. Then you can initialize the contract with new provider.eth.contract with the C uppercase. You send the ABI and the address as parameters. And then we can send the transactions. Instead of putting .call, we need to put .send. And then we need to specify the wallet the address that we are sending this transaction from. In this case, will be my wallet position 0 .address. And then Web3.js will do the magic under the hood to send the transaction to interact with the contract. So this is really important. These two slides of calling a smart contract and sending transactions to smart contracts will be really useful. Then for listen to events, something really important that you have to know is that when you listen to events, you cannot use HTTP providers, and you need to use WebSocket providers. So you need to initialize a provider starting with WSS. In this case, I just copy paste this one randomly. Then you initialize the contract, the same provider.eth.contract. You send the ABI and the address as a parameter. And then to subscribe to events, you need to create a subscription variable here. And then you use the contract instance, which is contract.events.event name. And then here you can put the event name that you have in the smart contract. And then you can just listen to the subscription by typing subscription.on and then the data, and then you, in this case, console log, and then you will get a new value printed every time that the event happens. We are going to see this later today as well. To send transactions, this is the easiest way that you can send transactions to the network. First, you need to initialize the wallet again with the private key. Then you can create a transaction object with the different parameters. You can include the from is mandatory and the to as well. Then you can send value, you can specify the gas, you can specify the data, other things. And then once you have this transaction object, you can just use the provider.eth.send transaction. You send the transaction object as a parameter, and then Web3.js under the hood will sign and send this transaction to the network. Something else a little bit more advanced for developers is to sign and send raw transactions. So in case that they want to sign the transaction and then just broadcast to the network this signature instead of sending this transaction object, they can use this as well. So they create the transaction object here, which is raw transaction. Then this object with the from, to, gas limit. I put also here the link in case that you want to see this. And then we need to use one of the account methods to sign the transaction. So we can access to the account by typing my wallet in the position 0.sign transaction. And then we send this raw transaction object that we have here. Then this signature will be stored in this variable sign transaction. And then we can broadcast the transaction to the network by typing provider.eth.send sign transaction. So in this case, in the case like previous case, we use send transaction, but then here we are using send sign transaction, which is different. And then we just send the raw signature as a parameter here. And then the transaction will be broadcast to the network. Here is also a useful link that you can visit. Okay, now Web3 plugins. Perfect. So this is what we are going to cover today. Just start. So Web3 plugins is basically a new feature that we released with the latest version 4 last year. These Web3 plugins allows developers to basically create any interface of SDKs for any Web3 project. Some of the basic use cases that we have discovered so far, but there are literally unlimited use cases here, are custom RPC calls, SDKs for any project, create easy Web3 APIs for Web2 developers. So we can provide some APIs for dApp developers or even a Web2 developer. They don't really need to know the mechanisms of Web3, and they can just interact with Web3 using JavaScript or TypeScript. So this will be easier for Web2 developers to transition to Web3. We can have contract wrappers. This in this case will be useful when you have to interact with that contract several times, or when you have a list of contracts, like for example, on Chainlink, where you have always the same contracts for the Oracle calls. So you can create these contract wrappers, which is basically just putting the ABI and the address within the plugin. So developers don't need to look for any ABI of any contract addresses, and this is just storing within the plugin. You can also do complex function arguments, decode or encode any argument that you want. You can also add any custom logic, functionality, external libraries. You can do literally whatever that you want. And then you can also have Oracle calls, like the Chainlink plugin, for example. These Web3 plugins are really good because that provide accessibility to all these Web3 projects. This will also increase adoption among Web3 and Web2 developers, because it will make easier the interaction with them. It's also really scalable because once you create a plugin, this is reusable code that can be used by anyone in the world, right? And also learning a plugin or an SDK is way easier than learning a protocol from scratch. So that's why the short learning curve for a project will be easier by using the plugins. So this is how you can create a Web3 plugin. We are going to see that later with Alexi as well. But you just need to install the Web3 library by running npm install Web3. Then we need to import the Web3 plugin base within these curly braces. Then we create a TypeScript class or JavaScript class, in this case, my plugin, which extends from this Web3 plugin base. For that, we just need to, you can reply to the questions. After that, we just need to create a name for the plugin, and then you can add any method that you want. You can literally do whatever that you want, send transactions, deploy contracts, interact with contracts, listen to events, use external libraries, whatever that you want here. And then how you can use this plugin. So after I created my plugin, in this case, so I just import my plugin from, first I need to install the plugin. So npm install my plugin, for example. You need to publish this in the npm website, like libraries, and then everyone will be able to install this. So yeah, I import this my plugin from the npm package. Then I just initialize the plugin. So let's say my plugin equal to new my plugin, and then I can just call the methods of the plugin, right? So in this case, my plugin dot do something, and yeah, and then this is really easy because then the developer at the end, they don't need to know what's happening in the background in these methods, and then they just call the plugin itself. So this is really useful. I'm going to be a little bit quick with these examples. So Chainlink data feeds, for those who don't know what Chainlink data feeds is, these are like a bunch of smart contracts on the chain that you call them to get the price of a pair. So in this case, can be Bitcoin pair with USD. So if I call a smart contract, that will retrieve the price 60K, right? So this is basically a Chainlink data feed. To be able to interact with Chainlink data feed, these are kind of the standard way. So you need to look for the ABI of the contract online or in the Chainlink docs. You need to look for the address of the contract that you want to call. If it's in the Ethereum mainnet or if it's in the Polygon or Arbitrum, it will be a different address. So you need to go through the different documentation to look for the address of the contract in your network. Then you need to initialize the contract by using the ABI and the address. And then you can make the call to the contract. And after that, you can show the result of the call, right? With the Web3 plugin, you just need to initialize the Web3 plugin, the Chainlink plugin, and then you can directly call the plugin, and that's it. And then, yeah, this is kind of the standard version. You need to import the ABI, the contract address here. We can create a new contract instance by typing new web3.eth.contract, the ABI and the contract address. And then we can call the contract the same way that I said previously, dot methods dot latest answer, because this is the function that we are calling in the smart contract, dot call, and then we'll get the result in this variable BTC price, and then we just show the result here. And then using the Web3 plugin, it's just like this. We just need to initialize the plugin, so a new Chainlink plugin, and then we just call the get price function, which is Chainlink plugin dot get price. We just send in this case, the mainnet and the pair that we are the network name and the pair that we want to call, that we want to use, right? So in this case, mainnet price fits.btc USD. And then the developer is not like, they don't need to know about the ABIs, they don't need to know about contract addresses. They don't need to initialize any contract. They just use this function, Chainlink plugin dot get price, and then they will get the Bitcoin price, right? ADA or Ethereum price or whatever, and then you show the results. So this is how the Chainlink plugin works. For the Superfluid example, so for those who don't know what Superfluid is an asset streaming protocol that allows Web3 businesses, games, DeFis to do kind of a streaming of crypto assets in real time. And then for developers to be able to use Superfluid, they need to interact with these forwarders contracts that are on chain. And then these forwarders contracts will redirect your call or your transaction to the host contract. So basically, the developer in the left will need to call the forwarders contracts, which are on chain, and then the forwarders contract will talk to this host contract, and then the host contract has like all the different logic on the core mechanisms of Superfluid, and then that's how you can interact with Superfluid. But then with the using the Superfluid Web3 plugin, instead of having the forwarders on chain, you can like all this functionality of the forwarders will be stored in the Web3 plugin, which is off chain. So that will be better. And then the plugin will directly talk to the host contract. So this is really good because in this case, we are improving the developer experience because the developer don't need to know all the core functionalities of the host contract, right? He can just directly or she can just directly interact with the plugin and they don't really need to know what's going on behind the scenes. This is also way better than the normal way because you're having less transactions and less calls. And then because we are having less interactions with the blockchain. So of course, this is minimizing the gas fees for the final user, which is great. So in this case, this is a really good use case. Okay, and then the Swisstronik example. Swisstronik is a layer one, and then to be able to interact with this layer one, you need to encrypt the data field of your transaction every time that you want to interact with the network. So if you are making calls or we are making transactions in your transaction object, you cannot have the data field like just sending this normal hexadecimal value all the time. You need to encrypt this in a special way that they have with some specific functions, and then you are able to send the transaction or send the call to the network. So the standard way is that you need to encode the function of the smart contract that you want to call. You need to encrypt the data field of your transaction. After you encrypt the data field, you can make the call. And then when you make the call, this like the nodes will send you like a encrypted value that you still need to decrypt after you get this value. When you get this value, you need to decode the value, which is a lot of things, and then you can show the results. But then all these steps, all this functionality is also wrapped into this plugin. Oh, okay, this was not Chainlink. This is Swisstronik. Sorry about that. You just need to encode the function that you want to talk, that you want to interact to in the smart contract. Then you can make the call using the plugin. And then all these things are happening under the hood of the plugin. Encrypting data field, making the call, decrypting the response, decoding the response, and then you just get as a final developer user, you get the final result, which is great. So this is the same. This is the normal way. So you need to encode the function by using this contract.methods.balance_of, and then in this case will be a ERC20 that we are trying to get the balance of this address. .encode ABI. Then we need to encrypt data field using this function that they have, encrypt data field. This will return two values, which are encrypted data and use encryption key. We can make the call, but then to make this call, we need to send the encrypted data. We cannot send the normal data that we are used to use in any other EVM networks. After we make this call, then we need to decrypt the response. When we need decrypt the response, we need to use all these different parameters, the RPC endpoint, the response that we got from the call, and then the encryption key, which is like a little bit overwhelming for developers. And then at the end, we show the results. But using the Swisstronik Web3 plugin, you just encode the function using contract.methods.balance_of.encode ABI. We make the call to the plugin. In this case, will be web3.swisstronik.call. So you are not making a normal call. You're actually interacting with the Swisstronik plugin. And then you just put whatever that you want here to any smart contract. And then the data, in this case, is this function that we are calling here. And then all the functionality will be like wrapped into the plugin. And then this will just return the final message here. And then we can just show the result, which is a really good use case. Okay, perfect. The criteria. So we have two things that we are hosting right now with Learn Web3. We have a hackathon. We have a buildathon, sorry, and then we have an ideathon. So the ideathon, you're not expected code anything, right? I'm going just to show you really quick what you need to do. These are the prices that we are giving here. So for the first place, we are going to give 900 USDCs, the second one 700, then 600, 400. Oh, this was the opposite way. Sorry, 500 and 400. Sorry, we have all the information, the proper one in the Learn Web3 website. Some useful links. And if you click here in template, you will come here, and then you will see what you're expected to submit as if you want to participate in the Ideathon, right? So I created like a simple template.md file. So the first thing that you need to do is to write an overview of your plugin. I have some questions here that will help you to get an idea of what you can write here. This is just text. Then the features of the plugin. So if you need to store any variables or any ABIs, any addresses, whatever, so you need to say, oh, in this plugin, I'm storing this, and that. So the plugin will be able to work. And then some functions, you don't need to code them, but you need to specify or explain what they are doing. I'm going to show you some other examples. Then we have some different categories for the plugin. If your plugin is a community plugin is something that will be used by general developers. Like, for example, we have this multi-call plugin or tokens plugin. So this is not related to a specific project. So you can just mark here X that this is a community plugin. Or if you have a project plugin, this means that your plugin is made to interact specifically with one project. For example, Chainlink, Superfluid, or Swisstronik. Then you can mark here. Or if it's another one, then you can just mark that here. Some of the use cases, this is really important. This is part of the criteria that we are going to judge. I'm going to explain that later. These are kind of the use cases or the benefits of using your plugin. Like, this is improving the developer experience, and why and how is improving it. Or maybe it's gas optimization, or this is doing something else. If it's doing something else, will be even better. I will get some extra points. Then you need to specify the usage. Like, okay, if I want to interact, a really good example of this usage is what I did with the Chainlink, Superfluid, and the Swisstronik plugin. Like, before, I need to do these 5 steps, and now after the plugin, I need to do these 2 steps or something like that. So that's really useful for us to understand what is your plugin doing. And then you need to have a diagram or a video explaining the idea or the process or flow of the plugin. And yeah, here I have just some little tips that I add here. Of course, we don't accept ideas to improve current plugins that we already have. Here is the link where you can find all the plugins that we already have, and we also don't accept ideas to like projects that we already have, like the Chainlink, Near Protocol, Superfluid, CK Sync, Chain Stack, etc. So if you want to see more ideas to get inspired to participate here, you go to this multi-call Ideathon proposal, and then here you can have an example of what is expected to build. So for category, this is community plugin, the use cases, this is improving the developer experience, this is improving the gas optimization, this is the usage, and so on. So yeah, that will be really useful for you, these templates, the examples. I also did a talk in ETH Denver, so if you want to learn a little bit more about plugins, you can go to this YouTube video as well. And then the submission, this is really clear in the website as well. But yeah, just the MD file. Well, it can be a PDF or Google Doc. We don't really mind, as long as you have all the different things that are included in the template, explaining the features, the category, the use cases, the usage, and the diagram of the video. And then for the Buildathon, these are the prices that we have. First place, 2,500, then 2,000, 1,000, 750, and 750. So for the Buildathon, you're expected to build an actual plugin. Here I have a lot of resources that will be really useful for you to get started building the plugins. Also the repository to the Chainlink plugins, Swisstronik plugins, CK Sync, multi-call. So yeah, you can just check their plugins to see or to get some inspiration, some ideas. For this submission, we are expecting that the plugin is compatible with Web3.js version 4 for X, a README file to be able to understand the plugin, that you need to publish the plugin to an NPM repo, and then you need to write tests for the plugin. to make sure that that works properly. And then the video will be a nice to have. The video diagram is mandatory for the Ideathon, but it's not mandatory for the Buildathon. But if you have one, you will get a little extra love from us. So that would be nice to have. And then if you want to publish your plugin, let me show you this. If you want to publish your plugin to web3js.org/plugins, because here we have different plugins. So if you want to publish your plugin here, what you can do is that you can go here. You can go to this repo here, which is the Web3.js landing, and then you can just add your plugin here. So I put the link here, a pull request to the Web3.js landing. That would be nice if you want to publish it there as well. The criteria. So this is how we are judging the whole Ideathon and Buildathon. This is the same criteria for both. So if your plugin is improving the developer experience, so how good or how impactful is this for the developers, like the before and after usage? We are going to qualify this from 0 to 10. So if it's something okay, we can give like a 3 or 5. But then if this is like doing, for example, the Swisstronik developer experience use case will be a 10 because you need to do a ton of things before. But then with the plugin, it's just a little function. So this will be a 10, for example. For the gas optimization, you can see the Superfluid use case. Before, you need to do 2 transactions or 2 calls to talk to the forwarder and then to talk to the host, right? But then with the plugin, we are skipping 1 transaction or 1 call to this forwarder. So if your plugin is optimizing gas in any other protocol, then this will give from 0 to 15 points. If you are having another use case that is not developer experience of gas optimization, then you can get up to 20 points. We are trying to find more use cases, so it will be nice if you can get new ideas here. Then what is the potential or the adoption of this plugin? If this is something that can be adopted like widely in Web3 or by Web3 developers, we'll also give from 0 to 10 points. And then the only kind of important part to note here is the implementation. Of course, for the Ideathon, you don't need to implement code, right? But then we are going to qualify like how feasible or the logic of your no-code implementation idea is. And then for the plugin builds, we are going to check like the logic of the plugin, the tests. Of course, we will appreciate if you write the plugin in TypeScript, but that's not mandatory. But you will get more points for the implementation part if you use TypeScript here. And then the guidelines. This is also in the Learn Web3 DAO website. A team can submit several ideas or several plugins. That will be fine. But then if you enter in both categories, you can only win 1 in each. So if you build, for example, a Uniswap plugin and then a Uniswap idea, you can only win 1, right? Just for you to know. In case of duplicated ideas, the first idea submitted will be considered. And then here, if you want to publish the plugin into the Web3.js landing page, and then the TypeScript not required, but will be highly appreciated. Okay, perfect. And now the last part of the workshop today, building Web3 plugins with our master Oleksi. So yeah, now let's build. I'm going to publish these slides after the workshop in the Web3.js repo, in the Web3.js Twitter, sorry. He's going to build these 2 plugins, the ERC20 plugin, and then the spreadsheet/Google API plugin. And yeah, I'm going to publish that with the repo code and everything. Please follow us, Chainsafe, Web3_JS. And yeah, that's everything. So now can go with Oleksi. Thank you so much, guys. Now I'll be here taking any questions.
Okay, guys. Can you hear me well, I hope? So let's jump to the code and create our first plugin. So the first one will be ERC20 plugin. So for this, we need to have ERC20 API. To find it, you can just Google. It's crazy, but you can Google ERC20 API and get it from some repo, or you can create the contract, build it, and receive the API. So we can copy. Let's create a file let it be artifacts, and create the const ABI. Okay, export. So I will work with TypeScript. Okay, and let's start from our website, web3.js.org. Here we have the docs. This is the documentation page. And here we have Web3 plugin for developers. To start create plugin, we can use the template which you already have. You can go to this repository, download this code, or clone this code. So I already prepared this for you to not spend the time for this. So if we do not use plugin, so we can just interact with the smart contract. For example, it will be ERC20 smart contract. Let's go to the app page, app folder, and in it to have the packages on, as you see file we have received, and install the Web3. This is the main thing. After installing, we can import the Web3 from Web3, and for example, as you see, I have the code already done here. So we can connect to the Web3, create the instance of the Web3. Here we provide the link to the provider, and then as Santiago show the example, Web3 as contract. This is the class, so we need to create the instance of the class and pass the ABI. ABI we have in artifacts, ABI. And then we can use this contract and call some method. Let me copy. For example, symbol. So every ERC20 token have the symbol. So we can do not use then, just call symbol, wait. Oops. Okay. This is the usual way, but all these things we can cover to the plugin. So in this case, I suggest to create a ERC20 plugin. So already copy the template here. This is empty template. So let's create something here and then use this plugin in our app and see how it will be easy to interact with the smart contract with the plugin. Okay, so let's make the name. This is template, so let it be, I don't know, ERC20 plugin. Here's the namespace. So it is a very important thing. This is when we will use our plugin. It will be in Web3 dot and our name, what we provide. For example, ERC20. Right now we don't have here, but after implementation, it will be here. Okay. And basically, we create a plugin, but we want to make something inside. For example, let's create function which make the instance of the contract. I like this. This. Okay. We need to have contract here because we don't have the Web3 instance inside the plugin. So we can use Web3 as contract package as separate. and create new contract, ABI, and let's set the param like contract address. And let's copy the artifacts to our plugin and use it here. Okay. What it won't. Void. Okay, it's not void. Also for Web3.js also have a lot of types inside. So we can just do not set the string here. It can be address. Oops. It's inside Web3 types. Let's install them. Okay, let's go to our Web3 plugin. And Web3 as contract. Okay. And let's make some few function. For example, we want to have a symbol. For this, we need to pass the address of contract address. So that would be like here. Get the instance, this contract address, method symbol call, and return. And what else? For example, balance, contract address, and just address. It's the address of wallet, which we want to understand to get the balance. Balance of address call. Okay, we have few functions here, and let's try to build it. Okay, after build, we have the lib folder, as you see here. And in packages zone, I change the name to Web3 Plugin Workshop ERC20 and description and link to the repository. And that's it. As you see, we have the lib index. This is our path to main.js file. And we have build here. So I built and everything works. And now I can publish the plugin. npm publish, enter. Okay, it asked me the ATP. If you never publish to npm, first you need to log in, maybe sign up, and then they have the OTP. So I need to provide the number. Done. Let's check the npm. So I just get my name, go to the npm, and use search. As you see, our plugin here. Yeah, you can change the description. It doesn't matter right now. So right now we can go to our app and install our plugin. npm install Web3 plugin workshop ERC20 and try to use it here. So how to use it? Also, you can go to our documentation page, go to plugin for users, and here's the code. So after creating the instance of the Web3, you can register plugin. So let's try Web3 register plugin, and create instance of our plugin. That's it. After this, we have in Web3 dot ERC20 because we set this in our plugin here to make type works and here as a namespace. Okay, and dot, and we have functions like symbol. So all this code we can delete. And that's it. We don't need artifact here. Let me remove it. Okay. This is promise. It's a sync. Okay, it should work. We need to provide the contract address because it want to connect, understand which contract to interact. Okay, I had some questions from you guys. Let's check.
Oh no, there was something about the artifacts, but no, that's fine. I answered.
Okay. So let's try to use it. I have the end file here. Okay, so to use it, let's install in our app.env just to use just to use the .env file. If you don't know what is it, npm.env, we can go here. It is just wrapper. Yeah, and we need just this link. Okay, and let's I need to have the correct provider here. I will use the mainnet. Oh, it suggests me already. Okay, so if you do not know what is the provider, you can go to the Infura or just Ethereum mainnet provider. Oh, not this one. Santiago, can you find the provider link and I will continue without it because I already have it. Yeah, but
That's fine. I have a question that it will be easier to answer right now. How can I access the chain ID in the plugin function? So can you show without the plugin you can access by web3.eth.getChainID. But now Alexi will show you how you can access the chain ID within the plugin. So yeah, are you able to? I will send you the link now.
Okay. So I provide this one, and I already have it.env file, my API key.
Sorry, you want for the mainnet?
Yeah, mainnet. So I will go to the Azure scan. Let's find someone, for example, USDT token. I don't know, any ERC20 token because we have the API for ERC20. And find some wallet. I don't know, let it be this one. Let's check. Yeah, this one has balance 1000. Let's copy the address. First, we need the address of the contract. I will create a variable. Oops. Okay. And then let's also get the balance because we already have this function. How I call it? Balance. Okay. For balance, we need contract address and user address, wallet address, I mean. this will be balance. Okay, and to run this code, I will use the TS node because this is TypeScript and we need to build it to JavaScript and then run locally. So to not do all these things, let's just write this npx, which if you npx will install the package if you don't have, but not inside your project. Just temporary. TS node, and then the name of the file. It is index.ts. Okay, this magic not working. That's amazing. Let's check. Yeah. So everything is okay, but I will tell you what happens. So right now here, when we create the instance of the contract, our plugin do not have ability to use this provider yet. Because here in our plugin, we create the instance of the contract like a separate package. And that's it. So to use the provider, we need to link our plugin to library, to context. For this, let's create this one instance. This link instance. And then return instance. That's it. Okay. Again, we need to, because we changed this code, so let's change the version of our plugin and go to Web3 ERC20 plugin, and again build. You can use yarn build or npm build, it doesn't matter, and npm publish. Again RTP. Once again, correct RTP. Done. Let's go here and npm update. So right now it should change the version of our plugin. Let's check. No, nothing. Okay, npm install again. Yeah, the new version. And we can run. Okay, once again the same. Let me check the link of the provider because it said we don't have the provider. You send the link in the chat.
Yeah, I sent it. Yeah.
This one.
Yeah, the one. Yeah.
Is it mainnet?
Yeah.
And it works without keys, yeah? Let's check how it works. Nope, the same. Okay, let me check this path to understand just is it a problem with our plugin or with provider? For example, get block. It's like usual process when you're programming something not working.
Yeah, that's true. Always debugging.
Okay, provider working. Let's check my provider also. Okay, it's also working. Let's check what happens inside plugin, because it looks like should works. Web3 plugin workshop here. So we have the contract instance, method symbol. Strange. Everything okay. But for the bug this, what the message is, 1 second. Hard.
Yeah, actually, can hard be used. We actually have a plugin for hard hat, so you can use hard hat with Web3.js. I will actually,
Yeah.
I will make sure to publish that link to Web3.js and hard hat in the tweet. So yeah, you will be able to use hard hat with Web3.js Coxie. Yeah, good question.
Okay. This should be vice versa. We need to add context to the contract, not the the contract to the context. What is the problem? So again, increase the version, npm run build, and npm publish. Oh, not here. npm run build, npm publish. Okay. Is it change or not change? Not change the version. Oops. It looks like it's not published. Okay. npm published. And let's check. Yes, new version, and try to run. Okay. Now it works. So we receive the symbol. It is USDT contract and balance of this poor guy, which address we just steal. So as you see right now, after we have the ERC20 plugin, we also can extend this with any function we need. It can be transfer, I don't know, what in decimals and other functions which you have here in, or maybe some logic. So the first plugin is finished. And if you have a question, please ask right now, and we will continue to the second plugin. So what are the questions we have here?
Actually, let me just read loud the questions that we have,
Okay.
so the people who are watching the recording will be able to listen to these questions. So the first one is, what if we want to interact with Arbitrum? So yeah, you can interact with any EVM blockchain using Web3.js. The only thing that you need to change is the RPC link when you create the provider instance. So if you connect Ethereum mainnet node or Arbitrum or Polygon, yeah, you will be able to
Yeah,
interact.
this one. Yeah.
Yeah, exactly. That one, just new Web3, and then the link that you want to put. there of the network that you want to use. How did you generate the artifacts? So for the ABIs and the bytecodes, Web3.js doesn't really generate the artifacts. So what I normally use is that I put the contract on Remix ID, then I can copy paste the ABI and the bytecode because Remix will compile the contract. How can I access the chain ID in my plugin function? So to access the chain ID, you need to link the contract of the instance contract to the context of the plugin. And then you will be able to interact to get the chain ID by just typing this.eth. And then yeah, that's how you get the chain ID. Then what else is here? Oh yeah, to use hardhat with Web3.js, we are going to publish the link to be able to use this too. Where can I get the RPC links from? So normally, if you want to get the RPCs, you can use Infura, Alchemy, QuickNote. But normally, I go to chainlist.org. In chainlist.org, you will just find a ton of free RPC uh, providers. That's useful for testing. I recommend to use those nodes for production or something else. But yeah, chainlist.org is a useful one. Yeah, so that's basically all the questions so far. Yeah, you can go ahead. Thank you.
Yeah, I want to show the Infura. You can go to Infura.io website, sign in here, and read the docs. Here you have all networks, and you can find all links, and also you can create the API key to use this blockchain, because some of these links should use it with API key. Yeah, that's it. And the next one, I want to show you how to create the plugin which use external library. It can be anything. It can be working with database or whatever you want. But in my case, we will create plugin which listen some ERC20 contract and write all events from this contract to the spreadsheet, Google spreadsheet. For this, we need to have, again, copy template from our repository and install external library. And also we need to have set up Google Workspace. For this, you can go to the Google Workspace and read what you need to do. It's like several steps: create application, credentials, etc. And let's begin to create the amazing plugin. Let it be Google Spreadsheet plugin. And namespace sheet. Let it be a little bit shorter. Okay, let's install Google. We need this. I found template. No. Okay. Google APIs sheet. This one. Install Google APIs sheet. What else we need? Looks like nothing. Okay, let's create the code. So what we need first, it's let's use our ERC20 plugin inside Google Spreadsheet plugin to not duplicate the data which we already wrote. So let's install this plugin also. This is like extra feature to use one plugin inside another plugin. Okay, import this one, ERC20 plugin, and create some function. Let it be init, which this added a register plugin and ERC20 plugin. Yeah, that's it. So this is the way how to add the plugin inside another plugin. Maybe it will be better to use constructor in this case, like this. But in this case, it will be a problem because when we use the plugins, as you see, first we create the instance of the plugin. And when we have the instance, we don't have the context yet. So if we put this code inside the constructor, it will be like register to nothing. We do not connect our plugin to the our context. So in this case, I create a separate function init for this and register plugin. Okay. What else we need? We need to start recording function, for example. It can be anything, start recording. And use, so right now we have this ERC20. Oops. Oh, we need to install Web3. That's why we have a problem. Web3, ERC20, and we need to have contract here. As you remember, contract, it just return the instance of the contract, this address. So we need to provide the address. So we need the contract address here. No, not only contract. And okay, we received the instance, and as you see, it's tried to understand what I want. As Santiago said before, we can use events and then transfer. Transfer is the usual ERC20 event, which always we get when somebody transfers the token to another one. And here we will have our subscription instance. Okay. And then we can listen the data on it and receive event, log event, as I remember. It should be, okay, without types yet. I will set later. And also we can subscribe on error. Let it be some, if you have some error to see it. Like this. Okay, so right now we start listening, but still have problem with types yet. I don't know why. So let's add Web3 types, event log. Yeah, event log. And here we have address. Okay. What else? We need to have the function which the save our events, because here in event, as you see, we can have the data like from address to address and value how much sent and data I mean, created at date of the transaction. So we have this data, and right now we can save it in the Google. As our workshop not about how to work with Google. For this case, I prepare some piece of code which initialize saving to the Google spreadsheet. So here we have save method. Let me copy and explain it. And also we need to have stop recording. Okay. So when we subscribe for the event, I don't know, we use a while this function and then we want to unsubscribe. So let's make subscription like a private variable because we don't need it outside subscription. It will be okay, type later. And here we have the subscription. And when we need to unsubscribe, we can just, no, not this one. This subscription, unsubscribe. And need, okay. Okay. Let's add some types here. So the subscription, it will be log subscription type.
Oh, sorry, Alexi.
Yeah.
From Web3, they just texted me that in around 5 minutes we need to wrap up. So yeah, try
Oh my God.
write at least the plugin, which is the most important. And yeah, let's skip the testing or the usage, but at least write the plugin so they will be able to know what to write.
Okay. In this case, let me copy the radio of the plugin, and I will show how what I do this and what it is. And that's it. So it's basically when we start recording. Where is it? Yeah. So we listen the ERC20 events. Okay, this ERC20. Yeah, it's okay. I don't know why it's not show the types yet. I listen the events and so I implement a little queue inside because when I put the data to the Google spreadsheet, it's not implemented on the Google side, so we need to implement it here because a lot of events we have at 1 second. So let's publish it and build and check how it works. Oh my God. The terminal is not working. Okay. And here. Oh, yeah. Okay, Google spreadsheet. Let's try to build. Let's check its type is correct or not. No, some problem. Possibly don't define it. Okay, as we have a lot less time, so I want to show you the radio version, but I will finish it and publish to the repository. So our app will be like this. So create a Web3 instance with provider, register the Google Spreadsheet plugin, set the Google authorization things, init function, which register the ERC20 plugin inside, and then start recording. I found this address like ERC USDT contract address, and all transactions from this address will be saved to my Google Sheet. Okay, this one Google Sheet. So I have it here. Let's start the code. Okay, set the up npx this node index, and here's I have my Google Sheet. As you see, we receive the transaction here, and it's immediately saved and add our Google spreadsheet. So for users right now, it's very easy to use. Users, I mean programmers. So just start recording any address, and it will start recording. Let's try again. Subscribing to SDT, and again, we receive all transactions, which happens right now. So we can go to the Etherscan and see all these transactions. And that's it from my side, because we don't have enough time. Sorry, guys.
Oh, perfect. I think that's great. So they will be able to get the main idea, and yeah, to be able to see how everything works. I also published the Google API key in the slides, so people will be able to set up the Google JavaScript key. And yeah, I think we don't have more questions. We already answered the ones that we have. We are going to share all the repository of these codes. Yeah, Coxie. We are going to share the repo in the slides, in Twitter as well. Yeah, just follow us.
You can already share the repo. It's without code yet, but repo will be the same.
Yeah, that's fine. Web3_JS on Twitter. And yeah, I think that's everything. Any more questions?
All right, I think we're ready to wrap up. If there's any more questions, make sure to reach out to us on the Discord. And thank you, Santiago and Alexi, for the presentation. And we'll have this uploaded by tomorrow. Thank you, everybody. Thank you, guys.
Thank you,
Have
guys.
a great day.
Thank you, guys. Bye.